In section 3.6.2, we'll examine a formula that's related to the sum to product identities, but is a bit different. This is called the reduction formula. Notice we're going to take a sum, such as what you see over here on the left side of the formula, and condense it into a single sine wave. So we are taking a sum and converting it into a single function, but this is different from the sum to product identities by the fact that both sine and cosine have a coefficient. So if alpha is an angle in standard position whose terminal side contains the point AB, then A times sine of x plus B times cosine of x is equal to the square root of A squared plus B squared times sine of x plus alpha for any real number x, where tangent of alpha is equal to B over A. Please correct my mistake on your notes. Change that ratio over there to B over A. So when we have the sum of a sine and a cosine term, we can condense it into a single sine function where this term would be the amplitude of that sine wave and alpha would be the phase shift of that sine wave. So this formula is really useful in graphing functions like what you see on example 3. It says use the reduction formula to graph one cycle of the following functions. We have y equals sine of x plus the square root of 3 times cosine of x. While we've graphed a lot of different trig functions in this class, we haven't graphed the sum of a sine and a cosine function. So we are going to condense this using the reduction formula. Keeping an eye on the formula up here, a is the coefficient of sine. So we can see in this problem, a is equal to 1. B is the coefficient of cosine, so we can see in this problem, B is equal to the square root of 3. We'll be able to condense this sum into a single sine wave that has this expression as its amplitude. So let's go ahead and determine that value. The square root of A squared plus B squared is the square root of 1 squared plus the square root of 3 squared, or the square root of 1 plus 3. That simplifies very nicely to the square root of 4 or 2. So the amplitude of our reduced function is going to be 2. Now we also need to figure out the phase angle. Tangent of alpha is equal to B over A. That is square root of 3 over 1. Now if you're paying close attention here, this is going to give us a unit circle angle. For tangent of alpha equal to the square root of 3, alpha would have to be pi over 3. Thus, our reduced function becomes y equals 2 times sine of x plus pi over 3. Let's go ahead and sketch this on the grid provided. This function exhibits a transformation to the left by pi over 3 units. To make this really easy to visualize, we can begin with the graph of our basic sine wave. One fundamental cycle of sine. I'm just going to sketch this in with a dashed line. Now, our new transformed function has an amplitude of 2. So we can also imagine stretching this sine wave up so that it reaches a maximum value of 2 and a minimum value of negative 2. To complete the graph, we can move each of those key points to the left by pi over 3 units. So pi over 3 units to the left of 0. Notice here this would be negative pi over 6, and this would be negative pi over 3. Pi over 3 units to the left of pi would end up right here, which would be 2 pi over 3. And our last point here at 2 pi would move left by pi over 3 units and land at 5 pi over 3. So the graph will begin and end the period on the x-axis, and halfway in between it will also have an x-intercept. Now the maximum point occurs at x equals pi over 2. If we move that left to pi over 3, it's going to land at pi over 6. So our new maximum would be here. And the minimum point, which occurs at x equals 3 pi over 2, would move left by pi over 3 units and land here at 7 pi over 6. Then we can sketch in our transformed sine wave. Now, these are very easy to verify that you have the correct reduction. If you'll go to your calculator, make sure you're in radian mode, type in the reduced formula and the original formula, and graph them both in the same coordinate plane. You should see that they represent exactly the same curve. Let's try example B. This time we have the difference between a sine and a cosine, and we're going to use the reduction formula to condense this into a single sine wave. So first notice that A is equal to the square root of 2, that's the coefficient of sine, and B is equal to negative square root of 2, the coefficient of cosine. To calculate the amplitude of our resulting sine wave, we're going to add the sum of the squares of these two values. The first one should be the positive one, square root of A squared plus b squared equals square root of 2 plus 2, square root of 4 again. It looks like we're going to get an amplitude of 2. To calculate the phase shift, we're going to apply the formula tangent of alpha equals b, which is negative square root of 2, over a, which is the square root of 2. For tangent of alpha to equal negative 1, alpha would have to be negative pi over 4. All right, why did I pick negative pi over 4? We've spoken very briefly before about evaluating an inverse tangent. Inverse tangent has a range from negative pi over 2 to pi over 2. That is, when I determine an angle by using an inverse tangent, I'm only going to give a value between negative pi over 2 and pi over 2. And in this case, we would find tangent of negative pi over 4 equals negative 1. Perhaps this is easiest to see if we convert our calculator into degree mode and evaluate inverse tangent of negative 1. Notice the result is negative 45 degrees, or negative pi over 4. So our phase angle here is negative pi over 4. So the reduction formula allows us to condense our original function into amplitude 2 times sine of x minus pi over 4. To graph this one, we can take the original sine wave, stretch the amplitude up to 2, and then move it to the right by pi over 4 units. So I'm going to visualize the original sine wave, this time with an amplitude of 2, and then we'll move that to the right by pi over 4 units. Because this scale already has pi over 4 units for every tick mark, this one's going to be very easy to transform to the right. That one's going to land off the grid, but that's okay. And we have our final sine wave. Once again, these are very easy to check with your calculator. Make sure you're in radian mode first, then go to y equals, type in the original function, type in the reduced sine wave that we determined, and double check to make sure that both graphs are exactly the same curve, and they are. So this is called the reduction formula. Again, not necessary that you memorize it, but make sure that you know how to apply that formula.